Hello everyone. Today we are going to talk about graphing linear functions from standard form. You know how to graph a line by making a table and then graphing it, but we're going to focus on two methods that we can graph lines a little bit quicker. The first one today we're going to focus on is standard form, and then we'll do our second method on Thursday. So graphing linear functions from standard form. So this says another way to determine whether a function is linear is to look at its equation. A linear equation can be written in standard form. Standard form is ax plus by equals c, where a, b, and c are real numbers. So they could be fractions, decimals, irrational numbers, whole numbers, negatives, really anything except for imaginary numbers, which we talked about just very briefly when we did the real number system. So these are numbers, not variables when you see them in reality. So this could be like 2x plus 3y equals 5, something along that vein. So determining if something is linear or not linear. We've talked about this before, but as a refresher, both x and y can only have exponents of 1. They can't be squared. They can't have radical symbols, anything like that. X and y are not multiplied together. They are either separated by addition or subtraction. X and y are not in denominators of fractions. They're not in exponents, and they're not in radical signs. So the table right underneath gives you some examples of linear versus not linear. So these are written. This first one's written in standard form, where you have your ax plus by equals c, where a is 3, b is 2, and c is 10. So this is a great example of standard form. Y minus 2 equals 3x. None of your x or y have exponents larger than 1. They're not multiplied together. They're not doing anything weird. They're just a normal standard x and a normal standard y. So we can rearrange this to be in standard form. So therefore it's linear. Same here. This could be rewritten into standard form. It also has nothing weird going on with your x or y, so that's linear. And then on the right-hand side are some examples that are not linear. So this one does not qualify because x and y are multiplied together. That's not allowed. This one doesn't qualify because x has an exponent of 3. And this one doesn't qualify because y is on the bottom. So we have talked about that briefly before, but that's just a reminder of how you can identify if your function is linear or not linear. So graphing from a table, we're going to review this. It was part of section 3.3, but just as a refresher before we move on, when you are graphing from a table, you can pick whatever x's you want. I like to keep things nice and small, nice and easy, but you can pick really anything for x. So I like to plug in 0. I think that's the absolute easiest. 5 times 0 is 0. 0 minus 9 is negative 9. Then if you plug in 1, 5 times 1 is 5. 5 minus 9 is negative 4. 5 times 2 is 10. 10 minus 9 is 1. 5 times negative 1 is negative 5. Negative 5 minus 9 is negative 14. And this would be negative 19. So you get the idea. It looks like only these three are going to fit on our graph. This is a 10 by 10, by the way. It's not numbered off, but the highest is 10, the lowest is negative 10. So there's 1, negative 4, and 2, 1. And then you can connect those to make your line. Really, you only have to have 2 points to make a straight line, but 3 I feel like helps you be a little bit more accurate, especially if you were graphing these by hand. On the computer, on Big Ideas and Desmos, they'll only make you put 2. As a reminder also, if you have y equals 5, this is kind of a special case where no matter what, all of your y's are going to be 5. You can still pick your x's, but all your y's are going to be 5. There's nothing to plug in. So this would be negative 1, 5. 0, 5, and 1, 5 is going to be a horizontal line. All of the equations where you have y equals a number and a number only are horizontal. And then x equals 3 is similar, it's just the opposite. So all of your x's are 3, no matter what, they're 3. And then you can pick whatever you want for your y. There's nothing to plug in. So 1, 2, 3. Those are my 3 points there. These are going to be vertical lines. So it's a vertical line where it goes through 3 on your x-axis. All x equals a number are vertical lines. So that's how we do it from a table, which I hope you knew prior to this. It was just on our quiz from yesterday. This is the new part, graphing using the x and y intercepts. So this is handy when it's written in standard form. Now, equations are not always written in standard form, but if they are written in standard form, then this is an easier method to get your line. So first, let's talk about x-intercept is where the line crosses the x-axis. It's where it touches the x-axis. Y-intercept is where the line crosses the y-axis, where it touches the y. So I like to, when I'm doing these, I'm still going to set up a table. But my x-intercept is where y is 0. And my y-intercept is where x is 0. So I just need to figure out what these numbers would be. So if I'm going to plug in 0 for y, really what happens here, what happens here is if I do 5 times 0, this goes away because it's 0. And now I have negative 3x equals 30. If I'm going to solve for x, 30 divided by negative 3 is negative 10. Similarly, if I want x to be 0, that's going to make this part go away. And if I do 30 divided by 5, I get 6. And now I have 2 points that I can plot. And connect to make my straight line. Now I still could have taken my equation and plugged in negative 2, negative 1, 0, 1, and 2, but it would have taken me a lot longer to get this same line. So this is just another method so you could do it a little bit quicker. So let's try that again on this example. Oh, also, I want to note, if they ask for the x-intercept, you would just type in negative 10. If they ask for the y-intercept, you would type in 6. If they ask for the point, what is the coordinate of the x-intercept, then you'd put in your negative 10, 0. Or if they ask for the coordinate of your y-intercept, you'd put in the 0.06. But if they don't ask for the coordinate and they just say, what is the x-intercept, you'd put in negative 10. So that's a little bit of a distinction on your directions there. All right, so on number 2 here, my x-intercept is where y is 0. So I'm going to cover up that y piece. 16 divided by 4 gives me 4. My y-intercept is where x is 0. So I'm going to cover up that x piece. 16 divided by 2 is 8. So I have 4, 0. And 0, 8, and then you can connect those to make your nice straight line. All right, these are not written in standard form yet, but I'm going to change them to be into standard form so that we can use our new trick. So remember, standard form is your ax plus by equals c. So to turn this into that, I already have a 4x. I'm going to subtract 3y from both sides since it's positive. And now I have 4x minus 3y equals negative 12. So I'm going to rewrite that. 4x minus 3y equals negative 12. And now it's in standard form, so we can use our trick. All right, so when y is 0, that means I can cover up my y piece. Negative 12 divided by 4 is negative 3. When x is 0, negative 12 divided by negative 3 gives us a positive 4. And then I can plot those 2 points for my nice straight line. All right, on this one, It's not in standard form yet because I have an x on both sides, so I'm going to subtract 6x from both sides, which will give me negative 4x plus y equals 8. And now I can do my trick. So when y is 0, it means I can cover up that piece. 8 divided by negative 4 is negative 2. And when x is 0, y equals 8. And there's my nice straight line. So that's it for our notes for today. Today's assignment is on big ideas.